Hello everyone, welcome to Nanotech YouTube channel. Today we are going to discuss how to develop a multiple outlet hopper. So as you can see from the drawing, this is our hopper and it has more than one inlets and only one outlet. So the idea of this hopper is to collect the product from different points of a bin or any other product source, and then gathering all this product into one hopper and then discharging it from a single point. So this is the drawing for a multiple outlet hopper. So let's start with the development. So this is Creo parametric 9.0 initial interface. So let's start with new part solid. I will uncheck this and I will choose MMNS part solid ABS and I will say OK. So let's start first with the front plane and I will use the revolve command, and here I will use a center line first like this. Okay, then we will start with the line command and I will prepare a rough sketch here like this. Okay, so this is our drawing. So let's start first with the top cover, which is whose diameter is 1180. So I will take half of it, 1180. So 590 would be the dimension from center to the corner. 590. So this dimension I will change to 590. Then the total height is 684, and from this point to this point it would be 684 minus 100. So I will take the dimension from this point to this point, which would be 584, and this last one, this would be 100 from this point to this point. Okay, so this one 584 and this one is 100. So this one is almost complete now. Now I need to see the outlet of this hopper, which is 200, and I will again take the dimension from here to here. It must be 100. So this is now complete, and now I will say OK, and you can see the hopper body is created here, and I will say OK. Now let's see here. So now we will start with the inlets. You can see we have multiple inlets here. So let's start with the first one. Here are the dimensions. So you can see it is 100 outside and 30 millimeter inside. So this is the thickness of this pipe, 1.2 millimeter, and the diameter is 150. So we will start with the okay. So first I would recommend to shell it, and then we will work on the top assembly. So first I will shell it from this point, and the dimension of this complete hopper is 3 millimeter. So here I will keep the dimension, the thickness as 3 millimeter, and I will say OK. So now you can see it is a hollow body from inside, and from top it is closed, and we will start with the multiple inlets here. So I will choose this plane first, and I will use the extrude command here. So now you can see from this drawing, at 900 millimeters these holes are distributed. So what I will do here, I will first create the dimension. So the diameter here is 900, so from center it would be 450. So from here I will take, so first I will take one circle here, and I will keep its dimension as 900. So this will be the center of our inlets. And then I will make a circle here like this, and the dimension of this circle I will keep it as 150 millimeter. So this one I can change to 150 millimeter. Okay, so now I will delete this line because I don't need that, and I will use only this circle. So here I will say OK. So you can see it is extruded in the outside direction. So now I need to know the height of it, which is 100, and the total is 130. So I will keep it as 100 outside and 30 inside. So this dimension I will change to 100, and I need this to be hollow from inside, and I will give it the thickness. So the thickness of it is 1.2 millimeter. Here 1.2 millimeter. Now I need to extend it inside as well, so I will go for option and side 2. I will choose variable. So here I will give it as 30 millimeter, and I will say OK. So now you can see it is extended outward to 100 millimeter, and from inside it is 30 millimeter. So the hole is created now. Now I need to make a extrusion here, so you can see the top cover is still in place, so this is actually closed at the moment. Now I need to make an extrude cut on this plane, and I will use the circle command here, and I will make one circle. So the diameter of it is 150. So 150, and I will say OK. This one I will flip inside the direction, and I will say remove material. Okay. So the dimension I will reduce a little bit because the other side is curved. So it is actually intersecting here, and it is making a hole here. So I will reduce the height here manually because I don't need to go down to the other boundary. I just need to make an extrude cut. So this one should be fine for us. So I will say OK here. Now you can see the inside is open and the sheet is removed from this area. So this is done now. Now we will make a pattern here. So for pattern I will go to pattern. The type I will change to axial. Now I need to choose the axis. So this is my center axis. And this I will change to angular extent 360. And you can see here the number of members. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So total we are having 9 number of holes here. So I will say 9 here, and I will click OK. So now you can see only one pipe is created and the other round are done, because we were doing the extrude command for extrude 2. So now I will choose this pipe, or I will choose the extrude 1 command, and I will apply the same thing. Axis, I will choose the center axis, I will choose angular extent, and this one I will change to 9, and I will say OK. So now you can see all the pipes are in place, which is fine now. Now we are having multiple options how to make the assembly from this point. Normally we are having an additional flange here, and we are having three or four supports here to hold this multiple outlet hopper in place. So for that we will make a flange type assembly on the edge of this multiple outlet hopper to place a support here. So for that I will again use the extrude command. I will choose this plane, and here I will draw a circle like this. So the dimension of this circle would be equal to 1180. As I said earlier, I wanted to make it a little bit offset, so I will choose this dimension 1280. The outside is 1280, and I will say OK. So here you can see this is created now. Now this height would be the thickness of my flange, so I will say 4 millimeter would be the thickness of the flange, and here I will choose this one. So 1280 is the outside and 1180 is the inside. So we are having a difference of 100 millimeter. So one side would be 50 millimeter. You can see it is created now on the outer edge of the hopper to hold the multiple outlet in place by using multiple supports here. So this is done now. Now as I said before, we need to make some assembly here for preparing the supports for this multiple outlet hopper. So again I will choose this plane, and I will use the extrude cut, and then I will draw a circle here. So this dimension would be 12 millimeter should be fine, and I will say OK. So this one I wanted to keep it as a whole, so I will flip the direction and I will remove material here, so which is already chosen, so I will say OK. So you can see the hole is created now, which is M12. So this is OK. So now I will repeat this as pattern. I will again go to axis, and I will choose the center axis. I will choose angular extent, and number of members 4 are fine for us, so I will say OK. So now you can see 4 holes are created here. Just to have a better overview, I would like to change this whole dimension. This one I will edit the definition, and here OK. OK. So this is fine. We will keep it like this, and the holes are in place. OK. So now let's look at the drawings. Here we need a slide gate of 3 millimeter, and it is actually used to open and close the outlet of this hopper. So let's prepare that. For this I need an extrude cut here, so I will choose any of these planes, this one, and I will choose extrude command here, and here I will make a rectangle starting from this point to this point. Okay, so here this dimension I can change to 5 millimeter because 3 millimeter is the thickness of the plate. So the rest is okay. So I will say okay. So here you can see it is extruded on one side. Then I will go for option and I will choose variable here too. And this one I can say to the next, and this one I can say through all. Yes, through all, and I will remove material. Okay, so this one we can set as variable. Okay, so since it is a hollow from inside, so we will keep it as none, and this one we can say through all, and I will say okay. So now you can see the slot is created for the discharge slide gate. So this is fine now. Now let's move to the slide gate that we will prepare separately. So, and we will prepare the supports in another window. Okay, so I will save this at the moment as part number 2. Okay, so now I will go for new part, and here I will uncheck and I will use MMNS part solid ABS, and I will say okay. So here I will choose the front plane. Simply I will choose the extrude command. From here I need to draw this slide gate. So roughly I have to see it is 200 is the length, so it is slightly outside, so I can say it's roughly 250 millimeters, and then we have a slight bend here. So I can say, let's make a rough sketch. So this one would be slightly lesser than 200, so I can say 195 would be the width of that plate, and this one I can say 250 millimeters. So I can say okay, and the height I can say 3 millimeter, and I will click OK. So here you can see the slide is created now. Okay, so now we need to round it here. Okay, so now we need to round these edges. This one, so this one I can choose and I can say round. So this one I can keep it as 250 or 200. And I say okay. The other one also I can choose this point and I will say round here again 200. Okay, so here this one we need to make a round of 100, and I will say okay, and this one also, because the diameter of that pipe is 200, so this round would be 100, which is half of that diameter of the pipe. So I will say 100 here, and I will say okay. Okay, okay. Okay, so now I will round again this point and I will say 100, or I can say 95. Okay, so now you can see the plate is created now. Now we need to make a angle here. So I will choose this plane, again extrude, and I will make a rectangle here starting from this point to this point. So here this thickness I will keep it as 3 millimeter and I will say okay. This one we need to extrude it to an optimum dimension, and this I can set manually. So this should be okay and I will click OK. So this is our insert plate which would be inserted at the bottom of the multiple outlet hopper. So this I can save as part number 3. Now let's go to the last one, new part solid. Here I will uncheck and I will use MMNS part solid ABS. Okay, so now we need to make the supports of our multiple outlet hopper. So I will choose the front plane, again extrude command. Okay, so here first I will draw a circle. So the dimension of this circle I can keep roughly as 20 millimeter and I will say okay. So the height of this support I can keep roughly to 1400 millimeter, or I can change it to 1000 millimeter just to have a better aesthetic. So I will say okay here. Okay, so now I will select this plane and I need to make a bolt here which would be fitting in here. The hole which we have created, this whole dimension was M12, so we will prepare a assembly here which would be M10 at least. So here I will choose extrude command again. I will use circle. This diameter would be 10 millimeter, slightly lesser than M12, and I will say okay. So this bolt I can change it manually, but if you wanted to give it an exact dimension, you can say 60 millimeter should be enough for this one, and I will say okay. So now we need some threads here. So in order to prepare the threads, let's first choose this plane and then I will go for helical sweep. Okay, so I choose this plane for helical sweep. Okay, so now I need to make first two references, this one and this one, the center line. Okay, okay, so once this is done, then I need a line here for threads starting from this point to this point, and I will say okay. So here I will choose sketch and I will draw a circle here like this, and this one I can say 2 millimeter or 1.5 or 1 millimeter. Okay, so then I will just trim the unwanted part here like this, and I will close this loop like this. So once this pattern is created, I will say OK, and you can see the threads are created now. Now I can change the pitch here, let's say 15. Okay, let's say 2. Okay, so 2 looks fine to me. Let's change it to 1.5. Okay, so this one is also fine, and I will say OK. So you can see the threads are created here. Now we need a base plate here. So for base plate, I will choose this plane, again extrude, and I will draw a circle here, or we will draw a rectangle here. So rectangle would be okay. So this center rectangle looks better. So I will prepare it somewhat like this, and I will say OK. So here we have threads here, and we have this angle here. So the dimension I would like to change to 100, and this one I can say 50 millimeter. So this looks fine now. I will say OK. This thickness I can keep it as 4 millimeter, and I will say OK. OK. So now I would like to select this one, and I will choose this corner, and I will round them. So this one I will change it to 20, and I will say OK. So this round we can OK. So let me see the dimension again. We keep it as 20. So I will follow the same for this one, and this one, and I will say OK. So you can see the support is created now. Now I need to make 2 extrude cuts here for the anchor bolts or fisher bolts. So I will create a round here like this, and this one M14 should be OK, and I will say OK. Okay, so this one I would like to change the direction, and I will remove material, and I will say OK. So the same extrude I will simply mirror to this plane, and then we are having 2 holes for the fisher or anchor bolts. So the support work is done now. Now let's start with the assembly. So I will first save this file as part number 4, and I will go to new assembly, and I will click OK. So here first I will bring the part number 2 in, which was over multiple outlet hopper. So this is OK. So then we need to insert the slide here inside. So I will go again to the assembly, and this is our slide gate, which I will rotate it like this, and then I will rotate it like this. So this face of the plate I will coincident it. So this will be the first point, this one, and this should be coincident with this plane. Okay, so you can see the plate is inserted inside. Now we can simply make their planes coincident, or I can simply change its position like this, because we forgot to make another plan here to make them coincident. So we can simply move it manually just to reduce the work and complete the job. So here you can see it is done. So I will say OK. So you can see the slide is inside. Now we need to add our supports in 4 corners. So I will go again to the assembly, and I will use coincident first, and then first I will choose their axis. So this is our center axis. This should be coincident with the axis of this one. Okay, so this one I can simply rotate it. Okay, let's do it again. So let's take the assembly inside, assembly number part number 4. So this is in the correct dimension now. So what I will do, I will simply, okay, so this is the threaded part, so I will simply rotate it in this direction. Okay, so I can make this face, this one. So let me set the first coincident constraint for this one should be sitting at this one, and then I will add a new constraint, again coincident. So this one should be here. Okay, okay, so this is done now. Now we need to add more supports on the remaining one. So assembly part number 4. So again we will simply rotate it like this, and then our first constraint would be this face, and the other one this face. Now we need to make a second constraint, again coincident, and this would be the axial one should be matching with here. So the second support is also installed. Now let's go for the third one here. and I will say OK. Assembly part number 4, coincident. So this is our face, first part of coincident, and then let's rotate it first. Then I will choose this face. Okay, so now we need another constraint here, coincident, and we will be making its axis as coincident. Okay, now let's go for the last one, assembly part number 4, coincident, and then I will flip the direction, and then I will choose first this plane should be coincident here. Okay, and then the second constraint would be from this axis to this axis, and I will say OK. So now you can see all supports are in place. I will simply turn off these all, and I will turn off this one as well. Okay, so this is our multiple outlet hopper Maka, and this is done now. You can see. So we need to install some bolts here, which we will do in the next section because the video is already gone more than the estimated limit. And here also I need an opening here, that would be only to check the product, so that is not mandatory, or that is not very necessary. So that's all for Maka. Further we can change the appearance here. If I wanted to make it, let me choose this all and change the appearance to this one. I can change it with reflections, and then I can choose again this all, and I will change again the appearance. Okay, so let me again choose this all. Okay, okay. Okay, so this looks better, and I think this is okay. So that's all for today. Thank you so much for watching the video. Please like, share and subscribe my YouTube channel. Thank you so much.